In this video, we're going to be looking at the normal approximation. We're going to be looking at how you can change from a discrete distribution to a continuous distribution, and in order to do that, you're going to need to do a continuity correction. The types of discrete distributions that we'll be focusing on and turning them into continuous distribution are binomial and Poisson distributions. You can approximate a binomial to a Poisson distribution, and you can approximate both to a normal distribution. However, as both binomial and Poisson are discrete distributions, you need to apply a continuity correction before you do a normal distribution. So I'll just explain how that works and then show you how to do it. With discrete distributions, we are generally dealing with integer values, so 1, 2, 3, 4, etc. The values in binomial and Poisson can only take these integer values. However, a continuous distribution, such as a normal distribution, could take any value in between any of these numbers. So a number such as 1.49 recurring is going to be also counting as 1, or would count as 1 from a binomial distribution. So we need to try and work out what our limits are when we are looking at a probability in a binomial distribution and then turning it to a normal distribution. So let's do an example. Here we've got a discrete distribution, a Poisson distribution. X is the number of customers who buy a drink in Sainsbury's per hour, and X has a Poisson distribution of 40. Now, if we're going to approximate this to a normal distribution, we need to do a continuity correction on this number here. So, if we look at the number 40 on a number line, and this is the best way of working out your continuity corrections. We know that we need to find that X is less than 40. So the numbers that we want are 39, 38, and all of those numbers in that direction. We don't want those ones. So the line that we're going to draw is there, and so that is the same as the probability that, let's say, Y, which has a normal distribution, is less than or equal to 39.5. I could have written it as probability that Y is less than 39.5. Because it's a continuous distribution, it doesn't actually matter whether it's exactly equal to that or not, because the probability of it being equal to an exact amount is going to be 0. Let's try the second example. So the probability that X is greater than or equal to 50, well, again, I'm going to draw the numbers around 50, so 48, 49, 50, 51, and 52. What are the numbers that we want here? Well, 50 is included because we've got that equals to sign, so we want that one, and all the numbers greater, we don't want those ones there, so I'm going to draw my line in between those two numbers, and so we can say that the probability that X is greater than or equal to 50 is equal to the probability that Y is greater than or equal to 49.5. Now the reason this makes sense is because 49.5 and the numbers above that will round up to 50. If we were doing this first one as a Poisson distribution, this would be the same as the probability that X is less than or equal to 39. And 39.5 and all the numbers below that round down to 39, sorry. Let's have a look at this final example here with a kind of double-ended probability. So I'm going to draw the numbers around 35 and 45. So 33, 34, 35, 36, up to 44, 45, and 46. So what are the numbers that we want? Well, X is greater than 35, so we don't want 35. We don't want any of those numbers, but we want 36. And X is less than 45, so we want 44, but we don't want 45 or 46. So when we're doing our continuity corrections, we're going to find that it's the same as the probability that y is in between 35.5 and 44.5. Now it's really important to draw the numbers so that you get the exact place where your continuity correction is going to come in. I just want to do a few more examples, all different types of permutations of examples that could come around. The last one, where it's equal to a certain value, is also normally students find that quite a tricky one. So let's just start with D and we'll get to that final one in a minute. So x is less than 60, so we want the numbers around 60 to help us work this out. So 59, 60 and 61. Less than or equal to 60 means we want 59, we do want 60, but we don't want 61. So we can say that x less than or equal to 60 is the same as the probability that y is less than or equal to 60.5. 60.5, of course, is in between those two numbers there. Let's look at the next one. Again, I'm just going to draw the numbers around around 40, and the numbers around 58. So 40 is included, 39 is not, and on this one 58 is included, but 59 isn't. So we would write this. There's our line, and there's our other line, so this is 39.5, and 58.5. On F, the numbers around 32, 31, 32, 33, up to the numbers around 50, so 49, 50 and 51. In this case, 32 is not included, but 33 is. 49 is included, 50 is also included, but not 51. So here we're going to be finding the probability that y is between 32.5 and 50.5. Okay, and finally now we're looking at an example where x is equal to a value. So again, I'm going to do the numbers around 45. And we've got to think, what are the numbers that we want? What are the numbers that we don't? Well, we want 45. We don't want anything else. So we're going to have to do a continuity correction on that, because 44.5 and above will round up to 45, and 45.5 and down will round down to 45. So this is the same as the probability that y is between 44.5 and 45.5. That doesn't really matter if we do these equal to signs or not, because we are dealing with a continuous distribution here. So quite an easy topic. Once you've got the hang of drawing these diagrams, these are the key to making sure you get the right answer every single time. But they're something that people forget all the time, so try to remember that when you are changing from a discrete distribution to a continuous distribution, ensure that you do your continuity corrections.